Hello.
Yes, sir.
Okay. So in this class, we'll try to write the linked list class, the structure or class for implementing singly linear linked list. Okay, so this is linked list. I think all of you have done the linked list code in C in the last semester. So we'll try to do the same, and in a using encapsulation, in using constructors, destructors, and default constructors, copy constructors, and all these overloaded methods. So if I talk about a singly linear linked list, so first of all, what we can see here, so we are trying to so there are few items shown here, and as a programmer, if I ask you that in terms of the object oriented design, how many objects can you see here? Am I audible? How many objects you can see?
4.
Why 4 objects? Is there any other answer?
Sir, 1.
Sir,
Somebody says 1 object. Somebody says 4 objects. Any other answer?
So 10.
sir,
10.
10 because each node is an object.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any other answer?
Sir.
I want to answer, I expect an answer something more than 10. Just to give an hint.
So 14.
14.
14.
14, sir.
Now again, I mean, maybe all are correct. And but I have got something in my mind, so that's why I would stick to this 14, but not all these. Okay. So now can you tell me what are the objects here? Now one who told me 4, what was in his mind when I called that how many objects are there? What did he see? Why he answered?
Linked list.
So he basically, so in his perception, these yellow, each of these yellow marked object, he treated it as a linked list because he was in a mindset like probably I am trying to write a single linear linked list. So in his mind, he was just focusing on identifying how many linked lists are there. To him, linked list is an object, and he was not interested in getting down further, or for even a more fine-grained observation, right? So that's the reason. And somebody answered 10. So who answered 10? It was, so when you answered 10, that is also in some sense it was his perception was, so he was not looking into the linked list as a whole. He just identified the smaller the smallest probable object that he identified. All these red ones, those are the nodes, right? Those boxes. So he said that 10 boxes. So that is also correct. That is not incorrect, but this is in one way correct, and that is in another way correct. And who answered 1? Why that 1 should be there?
Sir, actually I answered it by mistake. I just considered the entire single linked list as one object.
Okay.
I considered only one linked list, that's why I answered.
Okay, so this 4 and 10 is somehow it is acceptable, but 14, now I say that okay, this is correct. So there are 10 nodes, 10 boxes, but each of these 4 box, they form a linked list. And so basically each of these 4 boxes form a linked list, these three forms a linked list, this one form a linked list, and these two forms a linked list, right? So if I say how many, so then how many objects are there? There are 14 objects. So let us consider that this is the correct answer. So out of these 14 objects, how many category of objects are there?
2.
Right? So everybody agrees to that. So everybody agrees to that. So how many types of objects out of these 14? There are 2 types of objects, right? And what are those?
Node and linked list.
One is the node type, this kind, and another is what? Another is the object which is a collection of nodes, right? Connected by links. So this is one. This is a node type. So this is one type, one category of objects, and a certain category of object is better known as in object-oriented terminology, it is called as. So all these boxes, they do have some similar behavior, similar attributes and all. So all these kind of boxes, these 10 boxes, we call it as a specific class of objects, right? Hello?
Yes, sir.
Yes, sir.
So this is a class. So this class consists of how many items of this class are there? 10. So this class has got 10 instances. And now when I say so there are two broad categories. One is the box type and another is this entire unit is identified as an object because it has got some specific implications and meaning like that. So that is what I call is a linked list. So like this. So this is another. So how many objects of that type? 4, right? So this is another class. What is that called? So this is called a node class and this is called SLL class, singly linked list class. Now we have identified 14 objects and those 14 objects can be categorized in can be classified into two broad categories. And each category of objects we try to associate it with a particular name because of their distinct behaviors and their features that they share as common. And there is a node class and the SLL class. Now the second thing that we would like to see, is there any relation between these two classes?
Sir, has a relationship.
So SLL, what is an SLL? What is a single linear linked list? How I define it? How I define a single linear linked list? Now tell me quickly, don't take too much time. What is a single linear linked list? How can I define in words? It's a
collection of nodes.
It's a collection of nodes, then linked together. Now instead of writing collection of nodes, I can say it is composed of nodes. That is also possible, right?
Yes, sir.
It is composed of nodes linked together. So that means this composed means it's a composition. So the thing is, if you have already written a node class and if you know how to construct those objects of node class, how to destroy, how to construct and all this, probably writing the SLL class or single linear linked list class will be much easier, right? And so what kind of relation they should hold? What is the relation name?
Has a.
Or composition. So this is this actually models. So this problem, as per the perception, it actually models a composition kind. I mean, to be specific. Now, why do I actually uh, pinpoint the node within the linked list as a separate object? Because if I can do this, so this same node structure or this node class, maybe there are other data structures also which will be using the same these objects of node type, which can be also composed of nodes. Are you getting my point?
Yes.
Yes, sir.
So that's the reason. So this node class is something very fundamental, and that using that as a link of nodes, we can have something. Now you can have an array of nodes also doing something else. You can have many other cases. So this is a linked list. So the thing is, so that's why I would prefer not this one, but this view or perception. And once I prefer this perception, this actually comes up with two distinct class of nodes, which are by their nature they are related by the Hazard relationship. So this is basically the, what is this? The object oriented design, right? So this is the design of the problem that is given to us. This is a very simple and trivial design, but then real world problems comes up with very complicated designs, and the design itself, it has got some protocol how you specify, and there are several layers of the design so that you get more fine grained description of the things and all this. Okay, so this is what it means. Now the next question comes. So this is what we mean. A linked list is a collection of nodes connected to each other and all this. So next thing comes is, so to implement a SLL, first of all, which class do we need to implement?
Node.
The node class.
Node.
Okay. So let us first come to the design. Now we have identified two distinct classes for implementing single linear linked list. Now let us come to the node. So what a node is having? So how many, first of all, how many member data it will have? How many member methods it will have? Just look into it. So how many member data and how many member methods? Let us consider that it is storing integer values. Now tell me quickly, how many data members?
Two data members.
Two data members. For just for say additional scope for modification, we consider one more, that is, so this one is extra. In fact, the example that I have taken, I have gotten one extra field, but this is not necessary. So one is integer, that's the information field, right? It's a info. It's a link, and this is the extra, which is also integer field, right? So the next question comes now. So how many members are there?
Three.
Three member data. Now what will be their type? Private or public?
Private.
Private.
Private. Any other answer?
Public.
First of all, what do you think? What will be their data types? Info should be of,
Integer.
extra should be of, say, integer type, and link should be of. Now link is a pointer, right? So link is a
Yes.
pointer, as you can see. It's a pointer
Node
to
type.
whom?
Node.
Node pointer.
The node itself. So if I prefer to call it as node, so this structure, this is a schematic structure. If I call it as node, so this will be pointing to node type. Now the question, as I mentioned, so do I make it private or public?
Private.
Private. So if I make it private, then what do you think? Oh, okay, so before I do that, so let us let us talk about the member methods. How many member methods do you think it will require? Will be enough?
4.
One there will be a constructor, right?
Yes,
And
sir.
one there will be a destructor. It's a good practice. And then what else? A node class by nature, by itself, can it do something? A node class, is there any defined behavior for that, for which you need to implement a method?
It's a store value.
No, store value means once you construct it, you are basically storing values, right? So the construction of a node means you allocate the space and you basically initialize it. That's all. And maybe that you will be modifying the contents of it, maybe the info part or the link part through some other process. So the data structure which is actually going to use, which will be composed of this particular node, this box. So a data structure which will be composed of this box might have some methods to update or modify these member methods, right? But the node class itself, does it require any functions or specific functions? Are you getting my point? Do I actually need this box in isolation anywhere?
No, sir.
So it's just like a screw. So a screw is required or nut bolt is required only if you are doing something. Say you are developing some mechanical model or machinery or whatever, but by itself a nut bolt or whatever is of no use, right? It's just an accessory kind of thing. So just create it and keep it like that. So a node is also like that, but you say that this machine is composed of nut bolt, a screw, or this like that, a wheel. So like by itself a wheel is just a wheel, you just have it like that. But just having a wheel, it will not start rolling and all this, because you need a motor and all this, and then it makes. So this node, it probably will not require any other methods, but we can always add a display method just to make sure that the values that I actually stored is there. Okay. Destructor never returns anything, it never accepts something. Node, so what this node will accept, what do you think? What this
Info
node
and
constructor will accept?
Info and link.
Info, link,
How
and
many
extra.
arguments do you think it should accept?
3.
All the three, right? So it might accept, say, X, it might accept Y, and it might accept E. Okay. And so X, what we will do? So X may be the int, the info value. X will be storing the info value. Y should be storing maybe the link value. So link means it should be pointing to node. Is that okay? And
Yes,
E
sir.
should be also integer type. Now the thing is, now this is a constructor. Now the constructor, it might happen that you would like to create a node without passing any argument. When you are creating, you want to have flexibility, so that you can call node like this. You can call node like say 5. That means you would expect a node to be created, the space for the node to be created, where the info part should be stored value 5, right? Or you should be, sometimes you would like to have something like this comma, say some other pointer value, or maybe null. Okay, or maybe it is like this. Say we have got another node pointer, okay, say P. There are some codes, and we are passing here in the second argument, because the second argument is the pointer argument, right? So it is P. That means what? Through this construction, I would like to create a box. So probably this P is pointing to this box. It was already there. This is P. Okay. Now when I'm creating this new box, say it is this one, this blue box. Okay, so this blue box, when it is created, so it will be storing the value 5 here, but this pointer value, the link should be pointing to this one. So that's why I have passed here P. Is that fine?
Yes, sir.
But in
Yes.
this particular case, when I create this one, I am creating this yellow box by just passing value 5, and I don't care about this one. I don't actually pass this one. And in the first case, when I create this box, I just don't pass any value. I don't care to pass anything. In fact, they are all having the extra field. Okay. So the first case is this one where I pass nothing. And there may be even more, even one more case where I'll be calling node with 5 or say 15, then say P, then say 10. That means what? I'm passing all the 3 arguments, and so this is that box. I should expect it's 15. This should point to P or something else, and this value should be 10. Now if I would like to write it, so how many types of calls I would prefer? How many types of constructions?
4.
So if I would like to have in a single constructor this entire flexibility, what do I need to do? The concept that I discussed in the previous class.
Default
Arguments.
arguments.
Default argument. So what is the default argument for 10 for x? We really don't know. Let it be 0. Okay. So if I don't pass anything, it will be 0. And if you don't pass anything to this y, it will be what? It will be null.
Null.
Say for example.
Null.
That is generally the case. What will be the default for? So this is for null. What is the default for e? Nobody knows. Maybe it is -1. So that's the default case. Even when I call node 5, so this is 5, but this will be null because the default is null, and this extra will be -1 because we have set it to -1. Okay. When this third one is called, this is the first one, this is the second one, this is the third case. So third case is this one, so it will pass 5. This is fine, but this is -1. And the fourth case, we have explicitly mentioned all the 3 arguments, so this will be like this. Is that fine?
Yes, sir.
So we would expect a constructor which will be constructed by which will have all the flexibilities, and it will have the default arguments. If you have passed all these arguments explicitly, it will take care of that. If you have not done that, it will use some default values also. And this tilde node will be the destructor, which basically we'll see later on what it does, and the display is basically displaying the value of the info part and the extra part. That's all. Okay. So my question is now again coming back to that. So which one will be private, which one will be public? Now tell me this question, this answer. And if you have understood things correctly, you will be able to answer it correctly. Instead of jumping in just writing a code instantly, try to clear these issues. Like the design should be very much clear, and you should be able to justify your design. So which one should, so which of these, so what will be the data types? What will be the access specifiers for this? Tell me quickly. Do I need to make it public or private?
So public.
So as per me, it should be public, that so that we can modify them at any time we want.
Yes. So where we need to modify them for the first time? Okay. So you see, the constructors, they will be called by themselves. That's fine. But the thing is, if you recall this diagram where the linked list class will be using a node object. Are you getting my point?
Yes.
The linked list class is going to use a node object, maybe the first node or the first box, say this one or this one. So what it will do, the linked list class may have a method insert. So that insert is going to insert something or maybe update or increment the info part of a node. So if you have not made it public, a different class can it access a object, or rather can it modify the members of an object belonging to a different class which is labeled as private. If you label these as private, can the linked list object, can a linked list object which is composed of such boxes, this this node boxes, node objects, can modify this info part or this link part or extra part? Is it possible if you label it as private?
Yes, sir. Using a helper method.
Hmm?
Written. Yes, sir.
We would,
Using another method which would be present in the node class to replace the values.
Are you talking about the friend or what?
no, some member methods in the node class.
Or like a separate function can be defined,
No,
which will actually
my node class will have only these three. My node class is only having these three methods, nothing more. Because I do not want to have explicit explicit functions defined in the node. The node class is just this much. Whoever uses the node objects, they will define their methods, how to manipulate the node objects or how to add node objects, how to modify node objects. So if I make these all these private, can I ever be able to do something with these objects? Whoever wants to use it?
No, sir.
No, sir.
Are you getting my point? So somebody answered as private, but if I make it private, that is a problem.
Sir, can we do one thing that we make them protected and then inherit them in the private of the single linked list class?
Is it an inheritance case? Inherit means what? You are having something, you are trying to specialize that. So you have defined the student class.
Okay.
Now you say that these are UG students, these are PG students. Are you getting the point?
Yes, sir.
So is it like the linked list class is a subset of node class?
No.
So then where comes the inheritance? So these are all buzzwords, it's of no use. Right now, is it, so think of the design, is it anyway required? When the inheritance comes, you have got a group of students, so you have got a group of computers. Now you say that these are laptops, these are desktops, but they're all computers, right? So
Yes,
what
sir.
kind of relationship they hold?
And is there?
Is there a relationship between the linked list and the node class?
No.
So then how can you talk about inheritance? There is no question of inheritance here. Are you
Oh,
getting the point?
yes,
Is
got
the
it.
is the linked list class inherited from the node class?
No.
And if you, even if you force it to do so, it's a very bad design, because it's of no, because linked list is not a class, is not a node. Just simple speaking, linked list is not a node. Linked list has a node.
Yes, sir.
Got the point?
Yes, sir.
And there are other issues also when you talk about inheritance, how the private, protected, and all these gets propagated to the inherited class. That also is got, it has got some rules, and then the mode of inheritance also comes into place. So there are other issues, we'll talk about it later on. So got the point. So do we have any other alternative other than making it public? Anything else? No. Okay, so we have to make everything, all these three public, so that they can be manipulated, modified, or updated from any other class for which such node objects will be part of it, will be, it will be composed of that. Is that part clear?
Yes, sir.
And then what about this node, these constructors and this display? They need to be public or private?
Public.
Because
Public.
constructors, huh? Any other answer? Constructors always need to be public, because you have to call it, you have to invoke it, maybe from the main, maybe from other functions and all this. Constructors are executed from outside the class for sake of creating the constructing the object, so that should be invoked outside. Destructors also do the same. So constructors, destructors must always be public. And if you do not do that, compiler will give an error message immediately. And the display, let us assume that the display also will be called from somewhere outside, just to make sure that the box has been created with the appropriate values that I have asked for. Okay, so that's the design for the node class. Now what about the linked list class? Okay, I have got yeah, this is here. Now what about the linked list class, SLL class? Can you tell me what will be the members of the SLL class?
A
Better you
pointer to node.
look back to this basic diagram and try to answer. First of all, how you define a linked list? Definition is that it's composed of a node. It's composed of nodes, a set of nodes linked together. So when I define a class, when I define the when I provide the definition of a class, syntactic definition, the programming definition, what I look for in the minimal form, how a linked list look like. What is the minimal form of a linked list? Which linked list is of minimal form?
So one single node.
So in this case, why single? But because our null list also is having no nodes. But in this case, what we have assumed that every linked list is having a head node. Now that is up to the designer how we have constructed. So every node, you see, every linked list is having a head. We may not have a design with a specific head node. We can just have these nodes, and having a pointer pointing to the first node. That is also possible. But in my design, I have decided to have a head node, which in its info field, it will store the number of actual nodes which the linked list is composed of. So that's why it is 3. It is 3 here. It is 2 here. It is the third one is how many nodes are there in the linked list?
1.
No. How many nodes are there in the linked list?
0.
This is a head. Head is always a part of it. So head is not. So head appears to be as a node, but it is not the actual element node or the node which stores the linked list elements. Is that fine? So in that sense, it is having 0 nodes, and the second one is having just 1 node. Is that part fine? Now tell me, what is the minimal form of a linear linked list that we have identified here in its minimal form?
So there should be at least one head pointer.
Is it a pointer? What you can see here? What is this? Is it a pointer?
Node head.
It's a node.
A head node.
It is just a node, right? It is just a node. So what should be? So how many members should be there?
One head node.
Member data. How many member data should be there in a linked list, senior linked SLL?
1.
One head node and the info of the head node.
Again, you are confusing things. Once you have this head node, what is a head node? This is a head node, right?
Yes.
This is the head node. Head node means it includes all these. And you are talking about this info, it's already there.
Yes,
Okay,
sir. We only need a node pointer.
Getting the point. What I need?
A
Node
node.
pointer head.
That's all. This is the case. So what is a linked list? A linked list class. What is a linked list? It comprises of. So in the minimal form, what it is composed of?
A head node.
A node that we have just now defined, an object of that type, which is named as head. That's all, right?
Yes, sir.
So let us call it as head. I can call it as H also, doesn't matter. Let it be H. So what should be the type of that?
Node.
So is it a pointer? Is H is a pointer? What you found?
No,
What
sir.
is H? H means this one, this head, or okay, let it be head. What is head? Head is of type
Node.
Is that okay? Do you all agree with this?
Yes, sir.
Do I need to have anything else just to define a linked list?
So head to next equals to null you have to do.
No, that is a part of construction. I am not talking about construction. Try to listen to my question. My question is how many members it should have, member data. Do I need to have any additional member data? I'm not talking about what should be initialization values of those data of that member. I'm talking about how many member data should I have. Now I found that it is a single node. The node itself, I mean or a node object. A single node object should be the member data. Do I need anything else to define a linked list? That is my question.
No, sir.
No, sir.
So construction of a linked list means it has been constructed. If we have allocated a space for a single box, a single node, the linked list has been constructed. Now we initialize it and leave it for the other operations. That's fine. But do I need anything else? Because everything is there in the node. So how many nodes are there? It will be 0 probably initialized, and the link should be null, extra should be ignored, and all this. It's up to you. But we do not need anything else. Is that fine?
Yes, sir.
That is enough. And then what about the member functions, member methods? Definitely we'll have SLL, will have this one, destructor. Then we'll have maybe insert beginning. Maybe we have display. Maybe we'll have something more. Okay. Then delete beginning. Then we have got search, etc. Now my question is, so SLL, what do you think? What should be the different types of constructors? Okay, so before I do that, so what will be the data type? What will be the access specifiers for this?
Private.
So do you want to make it public? Anybody? Do you want to make it public? What is the basic what is the basic rule? What is the basic protocol? You should make things public until unless or you should tag members as private until unless you are forced to make it public. That is the rule, right? So you should not reveal the details of what things are there within the class, so that the user of the class should feel relieved. So the lesser the interface is, the better it is. The lesser things are revealed to the outside world, the better it is. Because try to hide the entire complexity, the number of data items, the members within yourselves by tagging it as private. But in this case, if I tag it as private, then what is going to happen? Sorry, I mean, if I make it as private, then can it work? So all these member methods, can it work?
No, sir. So we cannot pass, display function, if we pass, we cannot access this from the main function.
No, you see, these are member methods. See the point. These are the members of whom? Members of the SLL class. So the members of a SLL class. So if say in your family, you have your parents, your maybe brothers and sisters, and you yourself is there. So now if you have got something, say private to the family, I mean something that is used by the, say maybe the family locker, bank locker. So that is private. So private to whom? Outside the family, right? But within the family, everybody can access it. So if you tag it as private, will it be a problem for these member methods who are also a part of this SLL to access this head?
No, sir.
No, sir.
No, sir.
And to get access to the actual linked list, where should you start with? Where should you start with?
Head.
Because if you can reach the head, you can start, traversing through the entire set of entire set of nodes, right? So this node, this head member, if I make it private, there is no harm, we can access it from the member methods. Okay, but if I make it as public, then what happens? If I make it public, then what happens? Any other method, any other function, say like main, any other method like main, can it access that? Say I have created, say SLL, say you see SLL S1. What is S1? What is S1? S1 is a linked list object. Okay, is that fine? SLL is a linked list object, singly linear linked list. So this is a class object. So if I write here S1 dot head, what does it mean? S1 dot head means you are trying to. So how to access this info, this link, and this extra field of this head? How to access it? Using S1.
S1.head.info.
To info.
S1 dot head dot info. Is that fine? S1 dot head dot info. S1 dot head, because this head is a member of SLL class. So S1 dot head, it will give you, and then within that head, what you have got? Within that head, you have got info as a member. Is that fine? So the syntax will be S1 dot head dot info, S1 dot head dot link, S1 dot head dot extra. Do you agree with this?
Yes, sir.
Yes, sir.
Now the point is, now these, so what about this one? Info, link, and extra, these are all public. Okay, so these are all public, but the thing is, when you create this box is private. Can you see this? So if I write s1 dot, so can they be accessed? Can the head be accessed, or the information of the head, rather the information of the, or even the head, can it be accessed from any other function which is not a member of this SLL class? Is it possible?
No, sir.
No, sir.
So when I tag it as private, these are not possible. Do you all agree?
Yes, sir.
But you can always access head from here, right? Head dot something you can write. You can always access, because these are member methods. But this main is not a member. This is not a member of this SLL class, so you cannot do that. Is that fine? Are you getting the point?
Yes, sir.
But if I label it as private, if I would have labeled it as public, if this would have been labeled public, then what was the impact? Then if I label it as public, then s1 dot head is accessible from main, right? If instead of private I would have made it public, so s1 dot head would have been accessed, it will be allowed. Okay,
Yes, sir.
and then within the head, these members within the head, info, link, and extra, they also will be accessible, because this is also public. Fine. So that means you can not only access this, you can access this whole thing. So accessing this head info, if you make the head info to 0 forcefully or intentionally or unintentionally, what is the problem here? If you make it 0, that means even though there are actual nodes in the linked list, if you force it to 0, then what will happen? Some other display function or some other method, insertion and all this, will completely go wrong, right? Are you getting my logic?
Yes, sir.
It means, if, because this is public, this is public, you are forced to make it public, otherwise this will not work. Okay, this will not work means the classes which will be composed of this node will not be able to function. So you are forced to make it public. Now if you have made it as public, so if you do not make this as private, you see, if you do not make this as private, this head as private, then the contents of the head is public, but the head, if it is not public, if it is not private, That means you can access and modify, anybody can access and modify the head information, everything, and it will be completely, you know, it will be damaged. The structure can be damaged through that, because probably will be using the info information to traverse to know that how many nodes are there and do the rest of the things. Is that part fine?
Yes, sir.
That's why this will not be public. So it is something, I mean, the analogy is something like this, uh, as I would prefer to have it. হ্যাঁ লক্ষ্মী ক্লাসে আছি, পরে কথা বলছি তো। Okay, so it will be, you can visualize it something like this. So you have got a house. Okay, so 2-story. So this house, so it is 2-storied. So this is, so anything that you plant here, like you have in your terrace, you have got plants and all this, you have got something. Okay, so some plantations are there, and your neighbor is having a house here. So can you see this, what is planted here in the rooftop? This is visible, right? Your neighbor can see this, everything here. Is it possible? Hello? Hello?
Yes, sir.
Yeah, but if you have got a boundary wall, if you have got a boundary wall like this, and you have got a lock here in your, you know, in your main gate, so can you access this? So these are public, I mean, these are publicly maybe visible, or at least, you know that this is public, but can it be accessed? Can you access it?
No, sir.
Can you modify it? It is something like this, because you see this head is private, because the entry to that is, it's not allowed for all. Okay, it's only for the family members, they can enter and they can enter. So until unless you are not in the rooftop, you cannot access that, you cannot modify and all this. It's something like that. So this is public, you see. So these nodes are public, but how you access them, but you cannot modify those contents and all this. Are you getting my point, what I mean?
Yes, sir.
I don't know whether it's a very good analogy, but it is something like the previous one. The node structure, you have to make all the members private, public, otherwise others cannot use it. But when others are using it, they are using it via something which is made as private. So in turn, you basically make that the contents of those boxes secure. So you make sure that only through the members of this SLL class, those node structures, the head or the nodes pointed by head, can be modified or updated. So the entire structure is safe. So the thing is, you through a suitable interface, only through a suitable interface, through this display, insert, begin, delete, and all this, without using this interface, means without using these methods, nobody else can access, modify, and display the contents of it. So it is perfectly secure. Is that fine?
Yes, sir.
So what about this one? These methods? These methods may be public. Okay, so this is the overall design. Now I spend so much of time because just to have the clarification and justification of coming up with a design where we know that how what kind of relationship they bear, HAZA or ISA, what type of access permission should I give to the members, private or public. So that's a first thing. The rest of the things will be pretty simple, because you know how to write a constructor, you know how to assign values, how to assign default values, how to actually construct, how to deallocate, how to insert in the beginning. All these are known. So more or less the rest of the logic is known to us, but the object noted design of a linked list, single linear linked list, is clear. Okay, so can you focus? Can you see this? So these are complete node class. Is it visible?
Yes, sir.
Yes, sir.
So if you look into this, you see this is the node, this is the info part, this is the extra, this is the node link. And then as we have decided 3 arguments with default values. So v is 0, L is null, and E is 0 or -1 as you wish. Now what I did is just info is assigned the V, extra is assigned the E, and link is assigned the L. And then you write here node constructor as some display, so that you make sure that every time a node is constructed, this is invoked and you know that it is constructed. So later on, if it is done, then you can always comment it. If you are sure that is working, you can comment it. And this destructor, will the destructor do something specific here? Did I do any dynamic allocation in the constructor while creating a while constructing a node? Do I need any dynamic allocation? Got my question?
Yes, sir.
Do I need any specific dynamic allocation here? Do I need to call new here in this portion?
No, sir.
No.
No,
So
sir.
is there any specific need for the destructor? Generally, the destructors are undoing the things that you have done during construction, right? So this anyway, this initializations you really do not care because the node does not exist after this destructor is called. So those values will be ignored. But what we really care about in the destructor is to undo any dynamic allocation that we have done during construction. Is that part clear?
Yes, sir.
So nothing such happened here. So we really are happy that nothing need to be done here. Okay, so it is trivial, but still it is good to write there. And the display function, obviously you can display the cout, the value of the info, the extra, and the link, and you. So this is again just to check that whether things are correct or not. But once, as I mentioned, once I have done this, the constructor with overloaded values, and once we have included this constructor, the default constructor will not work definitely. So once we have done that, what is going to happen here? So we can have various ways of calling. So if I try to create a node like this, it will work. Okay, the first option, as I mentioned, this will work, this will work, this will work. And in fact, there may be other ways also to work. And if I would ever like to allocate a node dynamically, what should I do? Focus on this particular statement. What should I do here? So dynamic allocation. So this Q is a pointer to the node structure. Okay. Now a dynamic allocation means what should I call? New. What do I like to allocate dynamically?
A node.
A node. Now how I would like to create a node? I can specify the initial values. If I specify all the 3 initial values, it will do accordingly. If I can so in this case I have specified just one integer value. I can specify, say, as I mentioned, 20 comma null is already null, but that way I can do. Or I can even write another way of dynamic allocating a node is like new node, that's all. New node. That means even though I do not specify anything, it will also work. So once I have created this node class, I can allocate it statically like this. How to statically allocate it? Just like this. just write node n. It's a static allocation. Node n means it will call this version of the constructor. Okay, so this is a static allocation. Now the second one is allocating a node by invoking this version, constructor this version, but from the heap. It is dynamic allocation. Second one is also dynamic allocation. The first one is from the stack. The next and second and third is from the heap. Is that fine?
Yes, sir.
Yes, sir.
So this is just creating a node. That's all. So who needs to create a node? Probably the linked list, which will be composed of these nodes. So probably in the insert beginning, in that particular method of the singly linear linked list, in this method, in this insert beginning, in this particular method, there should be somewhere we may or we should call this new node. I mean, we should dynamically allocate space for a node, this box, with some suitable values. If we have, we'll pass it. If we don't have, we can just call the without any arguments, it will invoke that constructor, it will construct it. And then we should know that what to do with that, where to link that newly allocated node with the existing chain of nodes, that we have to decide. So this insert begin will probably call some of these ways of creating nodes. Okay, and the delete beginning probably will call what? Delete beginning will call
Delete node.
delete node, just to deallocate. That's all. Okay, and if you have got a destructor, it will, you know, that will be triggered and you know that it has been destroyed. Are you getting things? Is that fine till this point?
Yes, sir.
Yes, sir. Yes.
Okay, so can you see this? So now we'll focus. So I'll not take more another, say, more than, what is the time now? 5 to, so maybe 5 to 7 minutes I'll take. So I think we have not wrote anything, but this is important just to conceptualize the design of a very simple problem of writing a linked list. But you should have justification of what should be the design, where should I place it, and which one should I make private or public, the basic logic for that, and all this. Okay, so once you know this, you can implement a tree data structure. You can implement maybe some other data structures like, and in fact the nice thing is when we write hashing or graphs, so when we write the hashing code, we'll see that a hash table is basically composed of a set of linked lists. So that's a nice thing. So then we'll see that when you try to write a hash table class, so it becomes extremely simple, because a hash table is composed of a of a set of linked lists, and a linked list is composed of a set of nodes. So you have already implemented the node class, you have already implemented the linked list class. So implementing the hash table class, it becomes very trivial. Are you getting my point?
Yes, sir.
Yes, sir.
Because it is now composed of that. So when you write the hash table operations also, so hash table probably you will be searching for a node and deleting it. So you call the search function, the search method of the linked list, and then call delete method of the linked list just to do it. So basically deleting in the hash table, but performing a search followed by a delete, calling the methods of the linked list class, because the hash table is composed of linked list. Are you getting my point? So you don't have to write the logic afresh. So the hash table class will be comprising of maybe say 10-15 lines, because the entire complexity is handled was handled when you have implemented this linked list class, right? And the node class is also a part of it. So this becomes extremely easy for you to handle it. And in fact, when I write a graph class also, graph data structure also, we'll see that the same graph structure, data structure can be implemented in terms of linked lists. We'll see that how it occurs. So now, without writing too much of details, you can keep creating new classes which are composed of these existing classes. Got my point?
Yes, sir.
So try to get that idea. Just writing a code and then submitting it is not, so that is obviously important, but it is more important how you conceptualize your design and how you take the advantage of the entire object-oriented philosophy into it. Writing 5 lines of code, that comes later on, and that is a trivial thing, because anyway you know how to write the insert begin operations in C also, you know that. Okay, so I'll not go into the details of the hash and all this, so that will do it in Monday's class. So class SLL, you see, this is what we did, and then what is a method member data? It has got only a single member data, that is a object called head, which is of type node. And what is its access specifier? This is private, and because this class has got the default private, I have not even mentioned it here, because by default it will be considering it to be private, and but the rest of the methods I probably prefer to be to be all making us public. So this is SLL. So what is this? This is a
Constructor.
Now let's see now how many ways we can construct a linked list. So this way, so I could have made it even more simple, but here what I tried is, say if you are having a linked list like this. Can you see the linked list? And this is the head, because every linked list in our design will have a head node. And say this is 4, this is like this. Okay, so our linked lists will not look like this. So this could also have been a design, but we have preferred, so it was a like a head. So in that case, what is this? In that case, the head is just a
Pointer.
In that case, the head is just a
Pointer to a node.
pointer to a node. So if I would have opted for this design, what would have been the class members for SLL? What would have been the class members for the SLL?
Node asterisk head.
Is that fine? Everybody got it? And then the public members all start. So, but for this design, which we actually are preferring, or actually we have decided to go for it, in this case it is node just head, the entire object. So this entire object, so this is the object that you have trivially or initially. So got the difference between, so this is also possible and this is also possible, but we have opted for this in this case. So that's why our design is like this, our node. But this is also possible. If you have preferred this, you could have done this also. Is that fine? You got the difference?
Yes, sir.
But this much is only enough. For this much is only is enough to create or to construct a linked list, and then you can keep adding things accordingly. Now what I want to say is linked list SLL, the constructor, when I construct it, I may be interested in constructing say a green linked list. Okay, so this green linked list should be constructed. So once it is constructed means it will automatically get the space for, okay, I'm ignoring the extras now, the extra field now. So it will be constructing the head, that is fine. But what I want, during the construction only, I will pass, instead of null in that pointer field, I will pass the link to, say this particular node. What the point? So in other words, it will be something like this. So this linked list will be constructed. This linked list will be constructed. It is just my design, so it may not be always required. It will be constructed something like this. Maybe that I know that this will be, maybe that this will be of no use, and I am trying to create a linked list which is composed of some portions of some existing linked list. Is that fine?
Yes, sir.
So that means you may pass it as null when you are constructing it. That means the linked list will compose of the head node pointing to null. Construction is done. But you may also construct a linked list which will be constructed with some of the nodes, with the nodes from some existing linked list or a part of some existing linked list, where the starting node you have inserted. So you can just link it to this like that. Okay, so that is how I have probably complicated things, simple things, but again this is one option that I just wanted to show. Okay, so we have got how many arguments we need to pass here for constructing a linked list? One is if the head should point to some existing node during construction, you can do that. So how many arguments it should pass? One is the link, another is the extra. Okay, so that is how I designed it. You can do it in a different way also. So what I did, head, so head of info, it should be 0. So I have initialized to 0. So after it has done that, so what do you think? What should be the head count? If I have done like this, what should be the head count here?
So 3.
3. So for that I initialize it to 0, and then I use another pointer to point it to this, and then traverse through the list of nodes till I get a null, and I keep a counter incrementing by that and assign the counter value to it later on. Is that part clear?
Yes, sir.
Because I would like to have it here 3. That is what construction means. And so there are two things. You have to count and store the value here, and you have to point it to the value that you have passed. So that is what I am doing. So initially I initialize head info to 0, which will be modified later on, and head link to L. So if I have passed some value to L, it will be doing this. So this A is basically assigning, is taking care of this part. Okay. And then what I do, and extra is E. So extra field I am always passing, and whatever it is, either it is the default 0 or whatever I have explicitly passed, that is fine. And then if L is not null, if L is null, then it is fine, then nothing need to be done, it is already constructed, something like this. But if L is not null, then what I need to do, I have to use a counter to 1 and then another additional temporary pointer T, which is pointing to L. And then while T link is not equal to null, I keep on access traversing through the list of nodes, T assign T link like that, and I keep incrementing the counter by 1. And once I have done that, reach to the fag end of the linked list, I assign or update the head count, head info count to CNT, and that's all. Is that okay?
Yes, sir.
So it is basically unnecessary trying to create complications. So in most of the cases, probably will be passing here the null. So SLL, it is null if you, even if you have not passed it anything. So the null value, it is the default is null. So it will be considering, expecting that when you are constructing a linked list, you basically do not add any node to the head during construction, and you basically insert nodes by calling insert beginning or insert end or whatever. There will be some insertion functions to which you actually insert. Okay, so that's the case. And what is the destructor then? So destructor will be say from 1 to head info. So you have to consider that how many nodes you have to are there. and then what you need to do, t of head. So you use another temporary pointer t which it points to, and then head should be head link of head should be head dot what will be the case. So I would have to dispose of this node, but before I do that, I will hold it through the pointer t, and head should point to the next node following it. What should I do? How this b should be achieved? Getting me? Or I'll do it in the next class. May I stop here and we'll discuss in the next class, or is that okay? Okay, better I do it in the next class. Okay, so after we have done that, so this is the code. I'll share the code where it actually implements the whole thing, and then comes the hashing. Okay, and the hashing actually, you see here, can you see how big the hashing is? Can you see this, the number of lines?
Yes, sir.
Yes, sir.
So you see the hash function, this is just a, so hash function is there. So again, the theory of hashing, I think majority of you don't know, I'll discuss about it before doing things. So the actual thing is these are constructor, you see, and these are destructor, and then what we have, so these are the actual functions, delete from the hash table and then insert in a hash table, and all of them, they are actually using some of the single linear linked list methods. So they are so simple to write because I already constructed the detailed logic, and then search, that also uses some of it. So apart from that, nothing is there, and the display function is, we have customized display, and that also uses the display function of the SLL. So that's the end of hashing. So hashing is just writing a few lines of code. What the point? And this is a linked list class which actually takes care of the entire complexity, and it has got a copy constructor also. We can create a linked list, a clone of a linked list from an existing linked list. Okay, so this is much, the volume of the code is much bigger than that of the hashing, although the hashing seems to be a more, appears to be so complicated, but it's not the case, because hashing is composed of a collection of linked lists, array of linked lists, so like that. So I mean, that's the idea, that how object-oriented design, if it is properly designed, helps you to reduce the complexity of the coding. Okay, so are there any questions?
Sir, for the assignment given, we don't have to do the linked list question, no, sir?
So linked list 2 you don't have to do. I have already done it for you. I think by this time you should be able to do it. So I would expect you to, many of you to complete the linked list code having this design in mind to complete this code. Anyway, I'll discuss about it, and in the next class I'll be focusing on a little bit on the details of the linked list the methods, details of that, and then I'll straightway go to the hashing part, because hashing, it requires some discussion on the theory of the hashing so that you can actually write the code for it.
Sir, but keep this linked list question for next assignment, because today is the last date, so many would have already submitted.
That is fine. That is fine. So I'll just ask them to evaluate it out of, say, if it is, how many questions are there? 4 questions, no? Or 5 originally?
5 question including the
So,
linked list.
so now it will be out of 4 questions. So I'll ask them to evaluate out of 40.
Okay, sir.
But I would expect many of you, majority of you, to complete the linked list part, because I have entirely discussed the design. But the details, code, insert, begin, and all this, so try to write it of your own and see that what kind of messages, what kind of errors you are facing, so that you can discuss and debate here in the class on Monday. Because this is one, so this node SLL and hashing, if you can complete all of it of your own, syntactically, design wise, everything will be, it will be clear to you, and will be, so you can write anything and everything that you can think of. Okay, so design wise, there is no more things to learn in terms of the object oriented design. Any more questions? Okay, then I'm leaving. Thank you.